Okay, this is Math Primer Lesson 6, and I title this Algebra, Intro to a Variable. And let's start with the equation 1 plus 2 equals 3. Remember, it's an equation because it has an equal sign. Also, as a carryover from the previous lessons, there is an implied positive sign here and here. But again, by convention, we do not put those in. All right, this is an equation. Now, what if we took the 2 out and just put some kind of symbol there? 2 plus question mark equals 3. And we're going to use that question mark as a symbol to represent a value. And that is known as a variable, whatever that symbol is. And a lot of times the symbols are lowercase or uppercase letters or Greek symbols, or they could be whatever you want it to be. We could have 1 plus, see if I can do this, 1 plus a pickup truck equals 3. And what we're doing, again, is we are assigning a value to that pickup truck. This is a variable. And as we know, and it's very intuitive, the value of that variable is 2. By convention, though, we use usually an x equals 3. Or y. It could be just as easily written 1 plus y equals 3. It could be a z. It could be whatever you want it to be. As we said, a symbol. It could be a blob. You could have 1 plus blob equals 3. And again, that blob is the variable. Why do we call it a variable? Because at the time, we don't know what the value is. We have to solve for it, so it could be anything. It could vary between anything, and so therefore we call it a variable. All right, so switching back over here. 1 plus, I'm going to use x, equals 3. Again, very intuitive. You don't need to really solve for that. You don't have to think very hard about this equation to solve for what x is. Now, one very important way to think about this is a scale. Sometimes I call it a teeter-totter or a scale. And the fulcrum point is right there underneath the equal sign. So whatever the weight is, think of it in terms of weight, okay? Whatever the weight is here, that has to equal the weight there. Or in our case, the weight is the value that that expression represents. So let's put this back up, 1 plus x. This time I'm going to give us some room. And again, put that scale. And this, again, the scale is right there underneath the equal sign. And so if you think of it this way, whatever you do to this side, you have to do to this side, otherwise it becomes unbalanced. Well, let's start with 1 plus x. If we have to solve for x, which we really don't have to because we know what the value of x is, right? We know it's 2, and it's pretty intuitive, but most of the time that's not that intuitive. So if we're going to solve for x, what we have to do is put x by itself on one side or the other of the equal sign, and it really doesn't matter which side. So right now the x is on the left side of the equal sign, so we're going to keep it there. But to get x by itself, look what we have to do. We have a 1, and again, that's an implied 1, positive 1, I mean. Now, so what do we do to get rid of a positive 1? We subtract it. And we could just put it there. We could make room and put it in between there, but we don't have to because 1 plus x minus 1 is the same as 1 minus 1 plus x. Now what we have to do is put a negative 1 over here or a minus 1 over here to keep it balanced. You see what we've done now. This remained there. This negative 1 we brought over here, and the positive x is there. And because we added the negative 1 on this side of the scale, we had to include a negative 1 on this side, or a minus 1. Negative 1 and minus 1 I'm using synonymously. Okay, so now we can go ahead. 1 minus 1 is 0, plus x equals 3 minus 1 is 2. We can drop the 0 now and simply write x equals 2. which we knew from up here. Went through the process of solving for x. Okay, let's solve another equation. The equation 2 plus, and I'm going to just change things up so you can see it really doesn't matter what variable symbol you use. Now again, the first thing you want to do is think of this in terms of a scale. So I'm going to rewrite it to give us a little more room. Now again, just like last time, we want to isolate the value y by itself, one side or the other of the equal sign. We can do that by getting rid of this positive 2 here. Remember, that's a positive 2. So we go minus 2 on this side, but wait, guess what? If we don't do it over here, if we just put a negative 2 here, or subtract 2 here, what's going to happen to that scale? It's going to get lighter, and it would end up doing this, because that goes to 0, and it no longer balances. So in order for that not to happen, we have to do the same thing on this side of that equal sign as what we did over there, and that would be minus 2. So we know that this goes to 0, and we could write it as y equals 5 minus 2, or y equals 3. Important on your assignments and quizzes, always circle your answer. Okay, one more easy one just to change things up. Let's do 4 equals x plus 1. And it doesn't matter which side of the equation of the equal sign the x ends up on, it just has to end up by itself. That would be to subtract 1, right? Because that's a positive 1. So if we do it on both sides and think ahead and know that we're going to subtract 1, x plus 1 minus 1, that's what we added here, and this is what we've added here. We get 3 equals x. Because, again, this went to 0, and 3 is the value of 4 minus 1. And again, you want to circle your answer. Okay, let's do one more here and put a negative here. So how about 5 equals z? And this is the way I make z's. Just a habit I've adopted since my undergrad. Because in math, it's sometimes if you don't do that, a z can look like a 2. But in this equation, 5 equals z minus 4. So, and think of this as a scale. What are we going to have to do on this side? Instead of subtracting anything, we're going to have to add 4. We're thinking ahead, if we're going to add 4 here, we're going to have to add 4 over here. So we've got 5 plus 4 equals z minus 4 plus 4. This goes to 0. Z equals 9. And again, this was just to show two things. One, you can have z on either side of the equation, or your variable, and also just to throw in a negative to show that instead of, you don't always subtract to get rid of something, you may have to add it. Okay, let's go on to the next example. I'm going to clear this slate. Okay, in this example, let's do a multiplication. We're going to do 5 times a equals 15. So a couple of changes here. I'm using another variable, and again, you could use anything you want. You can use Greek letters, and sometimes they are used. You can use, as we saw before, pickup truck symbols, any lowercase or uppercase letter. But in this case, I'm using a, and also what's different is we've got a multiplication instead of an addition. So, just as before, we think of this in terms of a scale. This is a scale, this is a fulcrum point. Whatever you do on this side, you have to do on this side, otherwise it will become unbalanced. So we cannot subtract 5 because it is a multiplication problem. So to get rid of that 5 to make a by itself, we have to divide by 5. Again, whatever we do over here, we have to do on the right side. So this equation is still equal. We just haven't completely solved for the variable yet. And as you know, any number divided by itself becomes 1. So that is 1 times A equals 15 over 5. If you know your math if you know your math tables, that would be 3. 3 times 5 is 15, or 15 divided by 5 is 3. And by convention, we don't show the 1, so we just say A equals 3. And that fits back up in here. Okay, and along the same lines, let's try $14. Now this is a little tricky because look here, we've got B on the bottom in the denominator. How are we going to get B by itself? And it has to be on top. You cannot have 1 over B. You can, but it's not a very good method. You could have that, but that really doesn't tell you exactly what B is. It gives you the reciprocal of B. So just as before, on our scale, whatever we do here, we have to do here. And what we have to do here is to get rid of this B up on. Well, there's a couple ways to do it, but I think the easiest way is to multiply this side times B, and you have to do it over here as well. In this case, the B's cancel out. You get 7 equals 14 times B. And now we can do this, have to get rid of that 14. These cancel out. So B equals 7 over 14, or 1/2, if you remember your fractions. So in this case, we had to do 2 steps to solve for B. And in some algebraic equations, we will actually have multiple steps, and we'll be getting to that. Okay, that's an intro to a variable. This is the very beginning of algebra right here.